Recording in progress. Exercise 7, question number 5. Okay, so today's session is a bit challenging for you all. So listen to this very clearly. The sum of first 6 terms of any GP is equal to 9 times the sum of the first. Question number 5. A GP consists of an even number of terms. Okay, question number 5. It's on page number 12. A GP consists of an even number of terms if the sum of all terms is 3 times the sum of the odd terms, then find the common ratio. So now let us understand the GP. T1 is A, T2 can be AR. You can go on multiplying with R. T3 is AR square, T4 is AR cube, T5 is AR raised to 4, T6 is AR raised to 5, so on and so forth. Okay. So now the GP has even number of terms. The GP has even number of terms, okay? Right? So the sum of first 6 terms of sorry, I'm reading the wrong question again, sorry. If the sum of all terms, there are even number of terms, okay? So this will be T2n. This will be T2n. Why this is T2n? Because the number of terms are even. There are even number of terms. I'll be going very slow while explaining this. Okay? There are even number of terms. So the last term over here is T2n. Okay? Now sum of all these terms. Now this GP, this particular GP has T1 is equal to A. Okay? Then common ratio as R. Common ratio as R. But then the number of terms. Number of terms. How many number of terms are there in this particular GP? Is it n terms or 2n terms? Will you reply? Is it n terms or 2n terms? It's 2n terms. Okay. Please concentrate, please focus, otherwise you'll not understand this. There are 2n terms because even number of terms are there. So sum of all these terms, if we are adding all these terms, Sn is equal to A r raised to n minus 1 upon r minus 1. So we are finding out the sum of all these terms. Why we are using this formula? Because we don't know the value of r. This we discussed yesterday. Okay, so this is the formula. I'll put these values. S to n, A is A, n is 2n minus 1 upon r minus 1. So sum of all terms in a GP which has even number of terms. So first part we have done. These are sum of all terms which are in GP and the number of terms are even. Now the next part. It is 3 times. So this is 3 times the sum of all odd terms. So I'm highlighting all the odd terms over here. This is the odd term, this is the odd term T1, T3, T5, these are the odd terms. Okay. Right. So see guys, if there are 6 terms, T1, T2, T3, T4, T5, T6, there are 3 even terms and 3 odd terms. So if the total number of terms are 6, how many odd terms are there? How many odd terms are there? Please reply. 3. If there are 8 terms, T78, if there are total 8 terms, how many odd terms are there? How many odd terms are there? 4. So first I will just write down total number of odd terms. 2n by 2. See, the total number of terms are 2n. There are 2n terms. Okay, so the total number of odd terms will be 2n by 2, which is equal to n terms. Okay, so total number of odd terms are only n, they are not 2n. The total number of terms will get reduced by 2, divided by 2. Okay, so there will be n odd terms. Guys, have you understood this particular thing? Total number of odd terms. These are n. Okay, I'm going very slow so that you can understand. Now I'll write down all the odd terms. I will write down all the odd terms T1, T3, T5. T1, T3, T5. So this is A, this is AR square, this is AR raised to 4. Dot dot dot. These are the odd terms. And the total number of terms are n, not 2n. 2n are the total number of terms. And why 2n? Because those were even number of terms. Okay, the GP has even number of terms. So what is ratio over here? What is the ratio over here? The ratio over here will be r square. Are you convinced with me? The ratio is r square. Second term divided by the first term. So the second term is T3 over here. So the ratio is r square. So we'll find out sum of all odd terms. Same formula Sn r raised to n minus 1 upon r minus 1. What is n? What is n? Can someone tell me what is n? N is n because total number of odd terms are n. A is a. Guys, what is r? In the formula, what is r? For this particular GP, what is r? Anyone? What is r? R is r square. R is r square. Okay? R is r square. So finally, sum of all odd terms is equal to a into r raised to 2n minus 1 upon r square minus 1. Okay? 2 into n, 2n. Fine? Okay. Now the sum of the total number of terms, which is this, equal to 3 times the sum of the odd terms. Okay. So I'll just write sum of all terms or the total number of terms is equal to sum of 3 times sum of all odd terms. This is given in the problem. So this is a r raised to 2n minus 1 upon r minus 1, and this is 3 into a r raised to 2n minus 1 upon r square minus 1. These two values we have already calculated. I taught you this. This value and this value we have already calculated. So a and a will get cancelled on both the sides. Okay. R raised to 2n minus 1, r raised to 2n minus 1 will also get cancelled on both the sides. So we are left with 1 upon r minus 1, 3, r square minus 1 is r plus 1 into r minus 1. Again, r minus 1 will get cancelled, cross multiply. R plus 1 is equal to 3, r is equal to 2. Okay, so I prefer to go very slow with this problem, but then have you understood this? Please tell me. Please reply. Okay, so this was not a very easy problem. Okay, so some of you are asking why we are taking 2n. Okay, see these terms T1, T2, T3, T4. These are even number of terms. The total number of terms. Okay, it will be even number of terms. That means the total number of terms in the GP will be 10, 12, 14, that many total number of terms. So even is always represented by 2n, right? 2 into any number will give you even number. So these are the total number of terms. And in second case, total number of odd terms will be 2n divided by 2. Because if there are 8 terms, the odd terms will be 4. If there are 6 terms, the odd terms will be 3. So when I took odd terms, the total number of terms became n. I hope I have cleared your doubt. Okay. Yeah, so that problem we had not done yesterday, so we have completed this. Let's go to question number 8, sub question 3. Question number 8, sub question 3. Now sum to infinity is mentioned in the problem. The first term of an infinite GP is 1. Okay. So T1 is equal to A, which is equal to 1. It's an infinite GP. So we need to use that S infinity formula. Okay. Now any term is equal to the sum of the succeeding terms. So let the GP be AR square, AR cube, AR raised to 4 dot 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 dot. Given any term is equal to sum of all succeeding terms. Okay. Any term is equal to sum of all succeeding terms. So this any term, let this any term be T1. Okay. What is the sum of all succeeding terms? T2 plus T3 plus T4 plus dot 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 dot. Did you understand? I can take any term as T2 also. So the succeeding terms will be T3 plus T4 plus so on and so forth. But then for simplicity purpose, I am taking any term. Let any term be the first term itself, that is T1. I'll re-explain. T1 is equal to A is equal to 1 because the first term is 1. Let the GP be AR square, AR cube, AR raised to 4 dot dot dot. Okay, now given any term is equal to sum of all the succeeding terms. So if any term is T1, if any term is T1, what is the sum of succeeding terms? T2 plus T3 plus T4 plus dot 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 dot. And this problem is of sum to infinity, sum to infinity. It's an infinite GP where modulus of R is less than 1. Okay. Yeah. Now what is T1? Can someone tell me what is T1? What is T1? Anyone? T1 is A. Correct. T1 is A. So I'll write it on the next slide. A equal to. Now for an infinite GP, S infinity problems. T2 plus T3 plus T4 plus dot 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 is equal to AR upon 1 minus R. Just remember this formula. Only in sum to infinity problems. Huh? T2 plus T3 plus T4 plus dot 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 is equal to AR upon 1 minus R. sum to infinity problems. And if T1 is also included, then it is S infinity, and S infinity is equal to A upon 1 minus R. Okay. But then if it is starting from the second term, if it is starting from the second term, you have to remember this formula. So T2 plus T3 plus T4 plus dot dot dot, these are in GP, second term onwards. So this will be AR upon 1 minus R. You should remember this. A will get cancelled. 1 minus R is equal to R. 1 is equal to 2R. R is equal to half. R is equal to half. Guys, are you understanding this? Are you understanding this? Okay. So T1 is equal to A, which is 1. T2, A into R, 1 into half, which is equal to half. T3, AR square, 1 into half square, 1 by 4. T4, AR cube. Okay, so the GP is, the infinite GP is 1, 1 by 2, 1 by 4, 1 by 8. 1, 1 by 2, 1 by 4, 1 by 8. Okay, so now see, let me explain you this. Some students are having doubts over here. Now T1, T2, T3, T4, T5, T6, dot dot dot, this is an infinite GP. S infinity formula is A upon 1 minus R. What is the meaning of S infinity? Addition of all these terms. But then in S infinity problems, if we require addition of all these terms starting from the second term, the formula is AR upon 1 minus R. I can prove that to you, but then right now I'm restricting it. It's very easy. It's not that complicated. So if T1 is the first term, any term is equal to sum of the succeeding terms. Okay? Yeah. So this is the solution. Feedback, have you understood this? Have you understood this? If you have understood this, the next problem will be very clear. Question number 8, sub question 4. Question number 8, sub question 4. Now there is an infinite geometric series. So T1, T2, T3, T4, T5, this is infinite geometric series. So sum to infinity formula we can use. This is A, this is AR, this is AR square, this is AR cube, AR raised to 4 dot dot dot. Okay. Given first condition. What is the first condition given to us? The sum of the first two terms, A plus AR is equal to 5. A plus AR is equal to 5. Okay. Therefore, A into 1 plus R is equal to 5. Equation number 1. Okay. Again, that statement is occurring over there. Each term, each term means any term is 3 times the sum of the succeeding terms. So any term is equal to 3 times into sum of the succeeding terms. This statement was there in the previous problem also. Okay. But then here they had not mentioned three times. It was any term is equal to sum of the succeeding terms or each term, any term or each term. For simplicity purpose, any term, what will I take any term as? What have you learned from the previous problem? What is any term? What should we take it as? T1, correct. And what are the sum of the succeeding terms? What are the succeeding terms for T1? T2 plus T3 plus T4 dot. Guys, did you understand this? Have you understood this part? Anyone who is not understanding this? Okay. Now T1 is A. Now in sum to infinity problems, infinite GP sum to infinity problems. Do you know the formula of T2 plus T3 plus T4 plus dot? Have I given you the formula some time back? If yes, then let me know what is that formula. What is the formula of T2 plus T3 plus T4 plus dot? Only in infinite GP, if they are mentioning infinite GP or sum to infinity. What is this? AR upon 1 minus R. Perfect. So T1 is equal to A is equal to 3 into AR upon 1 minus R. A getting cancelled. 1 minus R is equal to 3R. 4R is equal to 1. R is equal to 1 by 4. Put R is equal to 1 by 4 in 1. A into 1 plus R is equal to 5. R is equal to 1 by 4. A is equal to 4. We got the value of A. We got the value of A. Okay. The GP I'm going to write right now. T1 is equal to A is equal to 4. T2 is equal to A into R, 4 into 1 by 4, which is equal to 1. T3 AR square, 4 into 1 by 4 the whole square, 4 by 16, which is equal to 1 by 4. T4, 4 into 1 by 4 the whole cube. So 1 upon 4 square, it will be 1 upon 16. So the GP is 4 comma 1 comma 1 by 4 comma 1 by 16, and this is infinite GP. Use infinite GP only when it is asked. Question number 8, sub question 5. Similar lines, very simple. If you have understood 3 and 4th sub question, this one is very easy for you. Fourth one. If each term of an infinite GP is twice the sum of all terms following it. So T1, T2, T3, T4, T5 dot. This is A, this is AR, this is AR square, this is AR cube, AR raised to 4 dot. Okay. What they have given each term. So any term is equal to twice sum of all succeeding terms or following terms, the term which is next to the any term. So for simplicity purpose, I will take any term as T1, 2 into sum of all succeeding terms, T2 plus T3 plus T4 plus dot. A is equal to 2 AR upon 1 minus R. Do I need to explain this now? Are you understanding? Yes or no? So A will get cancelled. A will get cancelled. Therefore, 1 minus R is equal to 2R. 3R is equal to 1. R is equal to 1 by 3. Problem is over. They are just asking the common ratio. No need to solve the next thing because we can't really get the value of A because one condition they have not given like the previous two problems. So they are just asking the common ratio. Okay. Are you done with this? Yeah. Next problem. Okay. Now S infinity A equal to 1 minus R, right? So this is the total from T1 to Tn. Same S infinity problems. The total from T2 to Tn is AR upon 1 minus R. Okay. Guys, you understood this? This we are discussing since last past like 10-15 minutes. The total of T1 to Tn in sum to infinity or infinite GP problems is A upon 1 minus R. But then the sum from T2 to Tn is AR upon 1 minus R. Now see, suppose there is an infinite GP. I'll give you an example. 1 half 1 by 4 1 by 16 dot dot dot. Here modulus of R is less than 1, so it's an infinite GP. So S infinity is equal to A upon 1 minus R, sum of all these terms. If we square this, now there is a new formula, you should remember this. If we square this, sum of squares of all these terms is A square upon 1 minus R square. Just remember this. As an example, I am sharing. 1, 1 by 2, 1 by 4, 1 by 16. Here modulus of R is less than 1. And if they are asking you S infinity or infinite GP, the sum is A upon 1 minus R. But then if you are squaring these terms, sum to infinity square will be A square upon 1 minus R square. Did you understand this? It is only 1 minus R square, not whole square. Okay, it's a proved formula. Let's go to question number 8. Question number 8, sub question 6. I hope you have copied this. 8 sub question 6. So sum to infinity, sum of an infinite geometric series is 15. So S infinity is equal to 15. A upon 1 minus R is equal to 15. Equation number 1. Read the first line. Sum of an infinite geometric series is 15. So S infinity is equal to 15. Don't use Sn formula. Infinity is mentioned over there. Okay. Now, sum of squares of these terms. So S infinity square, the concept which I just told you over here, this particular concept. S infinity square. Okay. So this is equal to a square upon 1 minus r square. And this s infinity square, this value is what? Can someone tell me what is this value? 45 a square 1 plus r 1 minus r. Equation number 2. 2 divided by 1 a square 1 plus r 1 minus r a 1 minus r equal to 45 upon 15. I'll do the cancellations. A and A is gone. 1 minus R is gone. Okay. 15 ones are 15 threes are. So 1 upon 1 plus R is equal to 3. Okay. See 1 minus R square I had written 1 plus R 1 minus R, then 2 divided by 1. Okay. After the cancellations, I'm going to write 1 upon 1 plus R is equal to 3. So what is the value of R? Can someone tell me what is the value of R? Yes. See, A upon 1 minus R, sorry, it is A upon 1, A is left over here. A upon 1 minus R is equal to 3. Fine? Yeah, I missed out that. Sorry. A upon 1 plus R is equal to 3. Clear? Therefore, A is equal to 3 into 1 plus R. A is equal to 3 into 1 plus R. Put in equation number 1. Now, what is 1? A upon 1 plus R, 1 minus R is equal to 15. Put the value of A. 3 1 plus R. Replace the value of A is equal to 15. 3 ones are 3 fives are. Chalo, calculate the value of R. Calculate the value of R. 2 by 3. That's perfect. It's the right answer, 2 by 3. Now, once you get the value of R as 2 by 3, calculate A. You can put R equal to 2 by 3 in equation number 1. Put R is equal to 2 by 3 in 1. You can also put it over here. Okay. But then we'll stick to that particular equation 1. Put R is equal to 2 by 3 in equation number 1. Get the value of A. What is A? What is A? A is 5. Correct? Okay. Yes. So T1 is equal to A is equal to 5. T2 is equal to A into R. 5 into 1 by 3. 5 into 2 by 3 because R is 2 by 3. Sorry. T3 AR square 5 into 2 by 3 the whole square. Okay. So 20 by 9 T4. At least go till T4. 5 into 2 by 3 the whole cube. 40 by 27. Okay. See guys, one thing I forgot to tell you. They are saying find the series. If they are saying find the sequence, put a comma. If they are saying find the series, put a plus sign. Sequence is with a comma, series is with a plus sign. Obviously, you don't have to calculate the total over here. Okay. Guys, did you understand this? Okay, so if you have understood this, go to page number 15. Question number 25 is for self-study. It's based on this problem. Sum of squares of infinite GP. Question number 25 self-study. Okay. Let's go to question number 9. Let's go to question number 9. I'm erasing all the slides. Read the question in the meanwhile. Yeah, 3 into half. So 3 I'll just write 1. Power is 1. 1 by 4. 1 by 8. Infinite. Infinity is mentioned in the problem. See, infinity. So 3 raised to 1 plus 1 by 2 plus 1 by 4 plus 1 by 8. The powers will get added as per the indices. Okay. Now, if you take a look at this bracket, round bracket, this bracket is R constant. Is R constant. T2 divided by T1, T3 divided by T2. Is it constant? You should always check. Is it constant? If yes, then tell me the value of R. If yes, then tell me the value of R. R is equal to half. Correct. We are only discussing the power term. Huh? Base is 3. We have nothing to do with that 3. Now modulus of R is modulus of half, which is equal to half. Modulus of R is less than 1. So there are two formulae. Sn when modulus of R is less than 1 and S infinity. Which one will you use out of these two? Out of these two, which formula will you use? You'll use Sn formula or S infinity. Correct. We are going to use S infinity because infinity is mentioned in the problem. Fine. Okay. So 3 raised to S infinity. This is S infinity. And what is S infinity? A upon 1 minus R. A is 1, the first term. By mistake, do not take the value of A as 3. 3 is not the first term. The powers are in GP. 1 upon 1 minus 2. Okay. So this is equal to denominator will become numerator. Answer is 9. Answer is 9. Clear? Guys, did you understand this problem? Yes or no? Hello. Just give me a feedback, please. Those who are attending, please give me a feedback. Okay, next one. Let's go to question number 10. Okay. T2 and T5 of a geometric series. They're not saying infinity over here. Infinite GP, they are not saying. Just a geometric series. R minus 1 upon 2n, 1 upon 16. So Tn for a GP, a raised to n minus 1. Put n equal to, there are two cases. So in the first case, you're going to put n equal to 2. And in the second case, you're going to put n equal to 5. So T2, a into r raised to 2 minus 1. So AR, and T5, a into r raised to 5 minus 1, which is 4. Guys, what is T2 given in the problem? What is T2 given in the problem? It's minus half. And what is T5 given in the problem? 1 by 16. Okay. 1 and 2. So 2 divided by 1. AR raised to 4 upon AR. This divided by this. 1 by 16 divided by minus half. So what is R cube, guys? What is R cube? What is 1 by 16 divided by minus half? What is R cube? What is R cube? Minus 1 by 8. Good. So what is R? What is R? R is minus half. R is minus half. Okay. R is minus half. Put R is equal to minus half in 1. Put this in equation number 1 and 10 will the value of A. Put this in equation number 1 and 10 will the value of A. Come on. A is equal to 1. Correct. A is equal to 1. So A is equal to 1. R is equal to minus half. Okay. Now they are asking S8. Modulus of R. Modulus of minus half, which is half. Modulus of R is less than 1. Which formula to use? Sn or S infinity? Please tell me. Which formula to use? Sn or S infinity? We'll use Sn formula because they are not mentioning infinity anywhere in the problem. So Sn A 1 minus R raised to n upon 1 minus R. So S8, what is A? A is 1. 1 minus R, what is R? Minus half raised to n. Okay, n is 8 upon 1 minus minus half. Okay, minus raised to 8 is positive. 1 upon 2 raised to 8 is 256 upon 1 plus half. Okay. Minus raised to 8 is positive. These things are important in binomial also. Minus with even power is plus and minus with odd power is minus. So 1 minus 1 upon 256 upon 3 by 2. 1 minus 1 upon 256 upon 3 by 2. Just solve this and check what is the answer. Are you getting the same answer as that of the worksheet? Great. Yes. Next one. Again, a new formula. The chapter is very big. Formula list is given to you already. Okay. So, whenever we know the last term in a GP, whenever we know the last term, you can use this formula. LR minus A upon R minus 1. LR minus A upon R minus 1. Where L is the last term. Where L is the last term. So question number 11, guys, very quickly. R is equal to 3. Last term is equal to 486. Sn is equal to 728. If this data is given in the problem, we need to find out the first term, that is A. So Sn is equal to Lr minus A upon R minus 1. 728. L 486 into R. R is 3 minus A upon 3 minus 1. Guys, please solve this and tell me the value of A. You have your calculators, you are well equipped. So please solve this and tell me the value of A. Correct. R is equal to 2. A is equal to 2, sorry. Question number 12. Self-study. You'll be using the same formula. Sn is equal to Lr minus A upon R minus 1. Sn is equal to Lr minus A upon R minus 1. Sn is equal to Lr minus A upon R minus 1. Okay. Question number 13. Question number 13. Let's proceed with question number 13. The third term of a GP we need to find out. T3 we need to find out. Okay. And what else is given? Common ratio is 3. R is equal to 3. S7 is equal to 2186. Now modulus of R is modulus of 3, which is 3. Modulus of R greater than 1. Sn R raised to n minus 1 upon R minus 1. Put n equal to 7, 8. Do we know the value of A? No. R is 3. 3 raised to 7 minus 1 upon 3 minus 1. Sn is given 2186. A 3 raised to 7 minus 1 upon 2. Okay. Get the value of A. Start. Someone please tell me the value of A. Solve this and tell me the value of A. Solve this and tell me the value of A. A equal to 2. Now how to get T3? What is Tn for a GP? A into R raised to n minus 1. Tn is equal to A into R raised to n minus 1. T3, A is 2, R is 3, n is 3. So 2 into 3 square, which is equal to 18. 18. Okay. Question number 14. Question number 14. The first term of a GP is 5. T1 is equal to A is equal to 5. The sum of the first three terms is 31 upon 5. Find the common ratio. R we don't know. So we can use this formula A into R raised to n minus 1 upon R minus 1 because R value we don't know. Okay. Sum of first three terms. So S3, A is 5, R raised to 3 minus 1 upon R minus 1. S3 is 31 upon 5. This is 5. A cube minus B cube. A minus B. A square plus AB plus B square. R minus 1. R minus 1 is getting cancelled. I will solve this further for you. Don't worry. Till here, have you understood? Any feedback? Have you understood till here? This 5 and this 5 will be multiplied. So 31 is equal to 25. R square plus R plus 1. 25R square plus 25R plus 1. 25R square plus 25R 1 minus 31. 1 minus 31 plus 25. Oh, sorry. Correct. Plus 25 minus 31 is minus 6 equal to 0. Minus 6 equal to 0. Okay. Guys, now if you really don't know to factorize the middle term, okay, you can also use formula method and finish this off. Okay. Those who are interested in the formula method, factorization method, 25 into 6, that is minus 150. Okay. So factorize this 150. So this is 5 and this is 3. So we got the factors 25 and sorry 30 and 5 plus 30R minus 5R minus 6. 5R 5R plus 6 minus 5 minus 1 5R plus 6. So 5R minus 1 phi r minus 1, phi r plus 6 equal to 0, r is equal to 1 by 5, r is equal to minus 6 by 5. Okay. Guys, please share a feedback of this problem, please. Please share a feedback. Have you understood? Okay. We should not discard the negative values of r. Yeah. Question number 15. Question number 15. The sum of first three terms of a GP is 2. That's the ratio to the first six terms is 125 by 152. So S3 upon S6, 125 upon 152 given equation number 1. So Sn is equal to A r raised to n minus 1 upon r minus 1, n equal to 3, n equal to 6, S3 A r raised to 3 minus 1 upon r minus 1, S6 A r raised to 6 minus 1 upon r minus 1. So where will we put these values, these two values? Where should we put these two values? In equation number 1. In equation number 1. Okay, I'll go to the next slide now. R3 upon R6, I'll put the respective values. So A R cube minus 1 upon R minus 1. A R raised to 6 minus 1 upon R minus 1 is equal to 125 upon 152. A gone, R minus 1 gone, R cube minus 1. Now R raised to 6 is R cube the whole square. So this can be written as R cube plus 1, R cube minus 1. 125 upon 152. Guys, did you understand this R raised to 6 minus 1? Yes or no? Did you understand this? Yes or no? Okay. So now cancel out this R cube minus 1. Now solve this. R cube plus 1, 152 upon 125. Solve and get the value of R. Plus 1 will go on the other side, it will become minus 1. plus 1 will go on the other side, it will become minus 1. Okay. So this is the end of the second session on exercise 7. Let's stop over here. Thank you.